Okay, so we're already recording. Yes, about the pre-lab. Thank you for reminding me. So the pre-lab is due at 6 p.m. today. So after our sorry, the lab activity from last week is due at 6 p.m. today. Okay, so after our pre-lab today, I will be creating a Google Drive folder specific for your group so that you can upload it there. So all submissions will be there. Okay. Um, Sorry, can I ask you to convert your pre-labs into a Google Doc format before you upload? Because if you upload it in a Google Docs format to the folder, I can make the corrections there na. Like you can see my comments. It's gonna be easier for everyone. Okay. So yeah, you just have to copy paste your pre-lab naman into Google Docs. So regarding the Google Drive folder, what I'll do later is right after this class, I'll create one folder for each group, okay? And I will send you a Gmail invite. So I'll be using your OBF accounts. So why is there one folder for each group? That's so that other groups can't access your lab report. Okay, so do you have any questions about that?
None, sir.
Okay, thank you. So wait lang. Sorry, someone's asking. For guide question number one, do we assume that the premise more than 50% recover is the new area of the study? Or sorry, I don't get the question. It's a direct message, guys. So there's a question. Uh, do we assume that the premise is the new study area? What do you mean? Please clarify. I don't get. Let me check then what guide question one is. Wait lang, I'm not sure. Sorry, Jessica, can you clarify your question? Okay. Wait. So guide question one is, suppose that you only want to take samples from grids that have 50% recover. Oh, okay. So yeah. Yeah, so that's what the first statement is about. So it says in the guide question that you only want to take samples from grids that have a greater than 50% recover. So yeah, that's what it means. So you have the correct assumption naman. And you do it in, wait lang. Yeah, you do it in your area. Okay? You do it in your area. I mean, it doesn't really matter. You can do it in any area. I mean, the question's kind of independent. Okay? So does that answer your question?
Sir, bali, we're going to stratify only the grades with more than 50% recovery.
Yes.
Okay,
Yeah.
thank you,
So
sir.
that's what you
Thank you
mean
po.
when you stratify your samples, diba? You
Yeah.
select from the viable ones. So
Okay po. Thank you
okay,
po.
you're welcome. Any other questions? Okay. Wait lang. Someone. No. What about uh what about the lab report writing process? Did you undergo any difficulties? Like, was there any part that you had a hard time writing? I just want to know. Anyone? Which part was the hardest to write? Syempre, I want to hear your opinions then so I can give you tips on how to write these parts for your future lab reports. Okay?
Sir,
Anyone?
how long is the lab report?
There's no maximum or minimum length for your lab report. As long as you're able to discuss everything in detail, then you should be fine. But I'm not gonna impose a maximum or minimum limit. So someone said conclusion. Okay, okay. Sige. Again, for the conclusion, wait lang. Okay, someone said conclusion. Again, direct message. All right, so when you're writing your conclusion, diba, you should revisit your objective. Okay? And when you're revisiting your objective, you do it in such a way that you use your results to answer that objective. Okay? So for example, let's say that your objective is, let's say the goal of your study is to determine the factors that affect precipitation in an area. Okay? And let's say that your results consist of temperature data, vegetation data, and the like. Okay? So what you then do is for you to answer your objective, you use the data that you have, okay, and you phrase it in such a way that it answers the goal of your study. Is that clear? So yeah, that's pretty much how you write the conclusion. Okay? So yeah, that's it. So does that answer your question? Okay, you're welcome. Anyone else? Any other difficulties in writing the lab report? How did you find how did you find the results and discussions part? Because that's the part that most students have, trouble with in writing. How did you find it? Was it easy? Was it manageable? Was it hard? What? Come on, don't be shy to speak up, guys. I'm doing this so that you have an easier time writing next time. So if you have any, you know, any qualms.
Sir, I think for our group naman po, it's manageable. Like, not too
Okay.
easy, not too hard, just it's okay.
All right. That's good. That's good. And it gets easier the more you get used to it. So yeah, the more you get sorry, the more you get used to it. And well, someone said it's kind of difficult to incorporate the guide questions. Well, the guide questions, I designed them in such a way that they're related, directly related to what you did in the experiment, or not really an experiment, but in the activity. So you really just have to find ways on how to insert the discussion for the guide questions within your discussions. Okay. Siyempre, I'm not gonna outright tell you, oh no, you put it here. No, I'm not gonna tell you that. I want you to think about how your discussion should flow. Okay? Because that's one of the challenges talaga of writing a paper. Fixing the flow of your discussions. So I want you to start getting used to it now, as opposed to learning it when you're doing your thesis. Okay? So this is in preparation for future research for you guys. But yeah, if you're having difficulties in incorporating guide questions, you can just ask me. Okay? I can maybe give you hints on how to do it. Basta, what really helps though is if you make an outline pala for your results and discussions or for your entire lab report. Just make an outline, and this gives you an idea of what to put and where. Okay? And it gives you an idea of how to phrase everything so that your guide questions or the answers to your guide questions can be inserted seamlessly. Okay? So yeah, try that maybe for your next lab report. Make an outline before you actually start writing. Okay? Any other questions, difficulties? So I'm assuming everything is clear. Okay, thank you. Sige. Let's move on to your second activity. Okay, so your second activity is somewhat related to the first. So it's still about sampling methods. This time, the sampling methods that you will learn about are number one, getting tree cover, so forest canopy cover, the like. Number 2, you have transects. Okay? And number 3, you have the cytoatobe method. So what are these? Well, yeah, we'll discuss it now. So let me just share the presentation with you guys. Okay, so this is our pre-lab for activity 2, which is about recovery estimation and transects. So I'll be uploading the worksheet for lab right after this lesson. Okay, so what is it about? First, you will be doing recovery estimation. Okay, so there are many ways of doing this. For example, if you're doing it in the field itself, okay, so if you're outdoors, you're in a forest, you want to estimate recover, you can use certain devices to do so, like a dendrometer. Okay, dendrometers are capable of doing that. But if you're like us right now you're just stuck at home, but you need to estimate recover, then you can also do so via satellite. Okay, so how do you do it? Well, there are instructions in your there are instructions in your worksheet. Okay, so we'll go through that later on. But please look at the picture here. Okay? So if you want to estimate tree cover or forest cover, how do you do so? Obviously, you look at the coloration, right? Green for trees. I mean, it's that simple. And scientists know that. Okay, so some scientists have developed ways of estimating tree cover via satellite data. Specifically, they use colorations in order to determine which area is covered by trees and which is not. So that's what this activity will be about. Okay. By the way, so this certain area is found in the Philippines. Where is it? Does anyone know? Oh, don't tell me now. Send me a direct message. And if you're able to guess by the end of the class, I will give your entire group a +2 for the next lab report. Okay. All right. So I won't tell you the correct answers now, but just keep the direct messages coming in. Okay. You get one guess per person. And the points will not be cumulative. You can only get a maximum of +2 per. All right. Oh, and I won't be satisfied with just the province. Give me the specific area in the province. Okay. So, what's the importance of estimating tree cover? Okay. So, on the upper left, we have a photo of that's Metro Manila. Okay. And on the lower right, we have a photo of Metro Cebu. Now, as we can see here, and as we can infer from the colorations, okay, tree cover is much greater in Metro Cebu than in Metro Manila. Okay? So that's one advantage of being able to estimate tree cover via satellite. Okay? You can do comparative studies. Okay, and what's the importance of doing comparative studies? What's an example of a study that will require you to look at tree cover? Can anyone think of something? What's an example of a study that would require you to look at forest cover or tree cover? Anyone? Seeking out. Let's see how you think. There are a lot of correct answers for this. Yes. So someone said again, direct message. Don't be shy, guys. You can use the public chat naman for this one, so that your classmates know, diba? If an answer's been given or not. But someone said deforestation. So yes, that's a very good that's a very good study. Okay, so if you're looking at deforestation comparisons over the years, then estimating tree cover via satellite would be a very viable option. Okay, what else? Oh, this is also a good one. Estimation of urban green spaces. It's actually a very interesting study. Okay, so let's say you look at the one for Manila. All right. So, diba, you can see that there's a specific spot of green in the middle. Okay, if I'm not mistaken, That's the Rizal Park UP area. No, not Rizal Park. Quezon Memorial UP area, if I'm not mistaken. I don't know. I'll recheck. Okay, but yeah, it's a very good way of estimating the amount of urban green spaces. Okay, what else? Let's say that you're looking at, let's see, study of canopy light absorption. That's also interesting. Yes, that's also applicable. So regarding how much light can be absorbed by a certain area. Okay? And in relation to that, you can also look at the carbon sinks present in an area. What do you mean by carbon sink? Okay, so the plants are able to absorb carbon dioxide from the air. Okay, so that's what you look at when you're looking at the carbon sinks in an area. So you're looking at the capacity of an area to be able to absorb carbon. Okay, so yeah, that's one. If you're trying to estimate recovery, so there are endless possibilities. Okay, there are endless studies that can use recovery estimation, okay? And that's what you will learn in this lesson or in this activity. So I'm giving you naman very specific instructions in the worksheet. So the instructions will tell you what to click, where to click. So it's a program that's available on Google Chrome. So you don't have to download any other specific applications for you to do this activity. Okay, so that's for estimating recovery. Another basic way of sampling in ecology is using a transect. Okay, so what's a transect? Simply put, a transect is most often a line that is used for sampling on the field. A line, when I say line, I mean a literal line. Okay, so what you do when you survey an area using a transect, you bring a very long rope. Okay, and you use this rope as a basis as to what environmental or organismic parameters that you collect, or as to what you collect. Okay, so let's say that I have a long length of rope on the beach. So I lay down this rope on the beach and I sample everything next to it or everything under that line, something like that. Simply put, that's what a transect does. Okay, but you can't just lay down a transect line anywhere. Okay, anywhere you want. No, there are there are good practices when it comes to laying down a transect line. One of the best ones you can do is when you're trying to measure the profile of an area that has an environmental gradient. What do you mean when there's an environmental gradient? Let's say that you want to measure the amount of seagrasses, okay? The amount of seagrasses in an intertidal area, right? What kind of environmental gradient would you find in an intertidal area? Anyone? When you say that there's a gradient, diba, there's a change in a certain parameter. So if you're looking at an intertidal area, what would you expect the gradient to be? Can anyone take an educated guess? Anyone? What gradient would you find? You already know about intertidal areas, right? From your first lecture. Uh, Someone said very extreme. Oh, yes, okay. Uh, the gradients in intertidal areas can be very extreme. Yes, but I'm talking about what kind of gradient would you find? Extreme in terms of what? Changes in? Anyone? Come on, think about it. Salinity, not so much, unless there are other factors that can greatly affect salinity. Uh, what you would expect, however, in an intertidal area is a gradient in water levels because of tides, right? Because as we have discussed in the first lesson, intertidal areas are constantly subjected to changes in tides, right? So, how would you expect this gradient to be? Of course, the farther you get from the shore, the deeper the water level gets. Okay? So if you want to put a transect line, in that area, then you would do it perpendicular to the beach. Why? That's for you to be able to sample from the shallower parts of the intertidal area to the deeper parts, right? So that's the environmental gradient that you have. Okay, in this case, depth. Okay, so when you're trying to sample in an area, you have to think of what environmental gradient can affect the sampling method or the sampling results. Why? Because if you sample your line in an area with no environmental gradient, then you're not going to be able to see patterns, right? But if you lay it down on, let's say, in our example, from an area of low water levels to an area with deeper water, then you might be able to see a relationship between water levels and whatever it is that you're sampling. For example, again, we mentioned seagrasses, right? Okay, so you may be able to see, let's say, a change in density of seagrasses with a change in water depth. Or for a more terrestrial example, let's say that you find an environmental gradient of sunlight with one area receiving more sunlight than the other. Okay, so you lay down a transect line in order to get the parameters from the area with high sunlight to an area with low sunlight. Okay, and what happens is you might be able to see a pattern as to how plants or plant height or plant presence can change between these two areas. Okay, so that's another example. Okay, do you have any questions about environmental gradients in general? None? All right, let's move on then. So we mentioned earlier that there are different types of transects. Okay, so let's discuss the three most common ones. Okay, so these three we have profile transects, line transects, and belt transects. Okay, so for profile transects, what you do is you merely record plants that occur on the line. You also record any slope changes that happen within specific intervals or any slope changes that suddenly happen. Okay, so for example, you decide to record slope changes every meter. Okay, so that's one viable way of doing it. But let's say that in between meters 2 and 3 of your transect line, you notice that there's a sudden 8 meter drop. Okay, so that sudden drop is notable enough for you to record it. Okay, so yeah, that's what a profile transect is. Next, we have line transects. So line transects, on the other hand, are used for recording plants beside the line. So this gives you a greater range of what to record in terms of area, since you'll be, excuse me, recording plants on both sides of your line. Okay? And many studies actually use line and profile transects in conjunction with each other. Okay, so some studies record plants both on the line, beside the line, and record slope changes. Okay, any questions? So for your activity, you will be using both profile transects and line transects. I'm not going to ask you to do it outside limit breaks. Don't worry. Okay, I'll just give you a worksheet with an example of a mapped area where you lay down your transect line. Okay, so I'll give you a certain situation, a certain scenario, and you lay down your transect line based on the scenario that I give you. Finally, we have belt transects. Okay, so belt transects are made up of two lines. So what ecologists normally do is that they just lay down another transect line beside either a profile transect or a line transect. And a belt transect is used for mapping vegetation, so plant cover, and slow animals that you find in between these two lines. Okay, and sometimes you also use another sampling method used for measuring plant cover, okay, with a belt transect. So you use a quadrat. It's spelled QUADRAT. So a quadrat is a grid that you can lay down in the middle of a belt transect. Okay, and that quadrat is used for measuring plant cover. So I'll show you a picture later, and I'll show you how to read a quadrat. Okay, but before that, before we get to the quadrat, I just want to show you an example of a transect line. By the way, guys, when look at this picture, this is not a scatter plot. Okay, again, this is not a graph. Imagine this to be a map. Okay, and each dot on the map represents a plant. So blue dots are species A, yellow dots are species B, and red dots are species C. So essentially, this shows you the distribution of different plants in one area. And look at the line from 1 meter to 10 meters. So that is an example of, just imagine it's a transect line that I laid down in that area. Okay. Sorry about that. You should be learning this on the field, but we'll have to make do with, a map like this. Now, remember that transect lines are normally laid down in an area where there's an environmental gradient. So let's say that I put this transect line here because there's a gradient in terms of sunlight. Okay. So the area closer to 1 meter, the 1 meter mark, has higher sunlight. And as you go along the line, as you come closer to 10 meters, okay, sunlight goes down. Sunlight levels go down. Maybe because of tree cover or other factors. Maybe there's overhead cover. Okay. So now, because we laid down this transect line with an area with a sunlight gradient, okay, we can use the parameters that we get for sunlight in terms of the specific demarcations and relate it to the presence of plants within each segment of the line. So, do you notice any patterns with the plants from 1 meter to 10 meters? What's the pattern that you find? Or is there a pattern? Are we imagining a pattern? Are we making up a pattern? Anyone? What about the blue dots? The blue dots are more or less evenly scattered, right? So are the yellow dots. But look at the red. Yes, so there you find more of species C close to the 1 meter mark and less at the 10 meter mark. So this is just an example of how you can use a transect line to gain an idea of how environmental parameters are related to organism density, right? So in this case, what kind of conclusion can you draw? Well, not conclusion. I mean, what kind of inference can you draw? Species C is found. Thank you for that. Someone answered again via direct message. Species C is more geared towards areas with higher light um, intensities compared to lower light intensities, right? So that's just one inference that you can make. Okay. By the way, I don't want you to make conclusions out of this. Okay. Sometimes, coincidences just occur. So all you make are inferences. Conclusions will come later on when you have data and previous studies to support your conclusion or your inferences. Okay. Any questions about transect lines? None? Okay, so we mentioned quadrats earlier, and quadrats are normally what you use with belt transects. Okay, so quadrats again are used for measuring plant cover. So I'll show you a picture. I don't have a picture. Sorry about that. But imagine a quadrat to look like this. Okay? So it's most often a metal grid a metal square made up of multiple grids. Okay? Most quadrats are 1 by 1 meters in terms of dimension. Okay? And what you do is you lay down a quadrat on the ground and you look at the plant cover underneath that quadrat. Okay? And you rate each square depending on how much plant cover there is. Okay, so you look at individual squares. All right, can everyone follow so far? Can you follow? You look at each individual square and you look at the amount of plant cover underneath. So let's say, for example, that this circle here represents grass. Okay, so you have a circular patch of grass on the ground and you lay down your quadrat on top of it. So what you do now is you look at this table, okay, and you look at the amount of cover and you grade each square in the quadrat based on the amount of cover that you find. Okay, so you rate it as class 5 if there is a cover that's around half to full for each square or for the specific square. Okay, and if that square is covered from 1/4 to 1/2, that's class 4. For class 3, it's 1/8 to 1/4. For class 2, it's 1/16 to 1/8. If it's less than 1/16, it's 1. And if there are no plants, then you mark it with a 0. Okay? So let's say, for example, you're looking at the top left square of this quadrant. What would you rate it as? There are no plants, right? It's not, part of the circular patch of grass. So you rate it as a 0. Again, why 0? Because there's no plant cover. Is that clear? But let's say that you're looking at the one that's completely over the patch of grass, the one that's completely in blue, that square. You rate that as a 5. Why? Because again, if the square has 1/2 to full cover, then you rate it as class 5. And you do it for all the squares. So I rated it for you guys. Okay, so 0 for all the ones on top, 3, 5, 4 for the middle, then you have 5, 5, 5 for the others, 4, 5, 4 at the bottom. Can everyone follow so far? Do you have any questions?
None, sir.
Okay, no questions so far. All right, thank you. Next, after you have rated each and every square in your quadrat, you get the frequency for each class. What does this mean? You count the number of 5s that you have. You count the number of 4s that you have. Okay, you count everything. So how many 5s do you have? You have 8, right? You have 8 5s in your quadrat. So you mark down the frequency as 8. You have 3 4s, you have 1 3, 0 2s, 0 1s, and 13 marked with a 0. So you get all those frequencies. Okay, that's very important. Why? Because you need those frequencies for this equation that you have here. Okay, so this is the equation for the Saito-Otobe method for estimating plant cover. Okay, so C, which is plant cover, is equal to the summation of M times F. What's M? M is the midpoint. So each class has a midpoint. So class 5 has a midpoint of 75. Class 4 has a midpoint of 37.5, and so on. Okay, and you multiply that midpoint by the frequency. Okay, so what's the frequency again for class 5? It's 8. Okay, so for the equation then you have 75 times 8 for class 5. And since it's a summation, you do it for all the classes. Okay, so it's summation of 75 times 8, close parentheses, plus the next class, which is 4. So 37.5 times the frequency for 4, which is 3. Okay, so I wrote them down here. This is the entire equation for our specific example. Okay, so again, 75 times 8 is for class 5. 37.5 times 3 is for class 4, and so on, until you reach class 0, which is 0 times 13, all over 25, which is the frequency. Why is it 25? Anyone? Why did we set our frequency as 25? Anyone? Why is it 25? Yes, okay. It's the total number of grids that you have inside your quadrant. All right. I I forgot to compute this. Sorry. Sige nga, guys. Can you compute? So what's the answer? Let me get my calculator. What's the answer? What's your C? Sige, I'll compute then. Okay, so I have an answer na. What did you guys get? All right, so we have the same answer. It's 29.25. Okay, so the plant cover in your area, in that specific area that you sampled, is 29.25. What's the unit? It's percent. Okay, it's 29.25% plant cover for this one. All right, so this is the last slide. So your worksheet will have a section about number one, tree cover estimation, number two, the Saito-Otobe method, and number three, about laying down transect lines. Okay, and since normally for the lab report for this one, I would make you do it in an area so that all your data is taken from that specific area. So all your data is connected. But obviously that's impossible to do right now, diba? Since we're stuck indoors. So when you do your lab report for this one, you don't need to relate your data between the three parts. Okay? Is that clear, guys? Again, you don't need to relate your data between the three parts. You can have three different segments for your results and discussions, one for each part. I'm not going to ask you to relate everything because that's going to be impossible. It's going to be too pilit if you relate the data for everything. That clear?
Yes, sir.
Okay. So do you have any questions?
None for me, sir.
Okay, sige. I'll show you the map for the last time before I close this file. Okay, so this is the one again that you have to guess. All right, sige. I'm gonna close it now. Okay, so again, just some reminders. Right after this class, I will be uploading the worksheet to your group, and I'll be creating the Google Drive, the Google Drive folder, okay, for you to be able to submit your lab reports. Again, the lab reports are due at 6 p.m. today. All you have to do naman is, convert your file to Google Docs, then place it there. Okay. So how will I notify you about the Google folder link? I'll send you an invite via email. Okay. So each folder will only be accessible to you and your group mates. Is that clear? Do you have any other questions? None? All right. So I'm going to tell you the answer now. So no more answers after this one. It's Mariveles, Bataan. Okay, that's Mariveles, Bataan. So it's the Five Fingers area, Five Fingers Cove in Mariveles. So everyone who got it right, you get a +2 for your lab report, for your next lab report, for your entire group. Okay, so if you have no more questions, then that ends our pre-lab. No more questions? None? All right, so thank you guys. I'll upload the worksheet right now, so you can start if you want to, and I'll also create the folders now. so you can submit. All right. Thank you guys, and
Sir,
have a good day.
excuse
Yes.
excuse me.
Yes.
Note nyo na po yung name, sir, nung sumagot sa
Yes, I'm
sa
gonna a
gifts.
lot of people got it. So I'm gonna record everything once
Okay.
everyone leaves. Yeah. I have a
Okay.
record
Thank
naman
you,
of the
sir.
chat. Yeah. Don't worry. Don't worry. All right. Sige. Have a good day, guys. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
All
Thank you,
right.
sir.
Thank you, sir.
Bye.